Okay, good morning class. So at this point we've read through half of the explanation of the inverse function, the introduction basically. We're looking at the examples for exercise 2 on page 39. So the question is how, now we are told how to find the inverse of a function. We replace f of x with y, swap x and y, solve for y in terms of x, replace y with f to the minus 1 of x if the inverse is a function. If it's not a function, of course we don't replace it with that. Okay, but we'll see how it works out. How to plot the inverse function? Sketch the graph of f using key features, namely intercepts, turning points and asymptotes. We use the values 1, minus 1 and 0. Okay, so you can put that in there. We use x to be, you can use anything you want. Okay. Minus 1, 0 and 1. Okay, and then draw the line y is equal to x, the line of reflection or symmetry. Deflect the key points on the graph of f above the line y is equal to x to sketch the graph of f to the minus 1. Okay, so I'll give you a chance to write that down quickly. Just going to pause the video at this point. Okay, so let's look at the examples. We are told to remember the notation f of x for the function f of x is equal to, the inverse is f to the minus 1 of x, interchange x and y to make y the subject of the formula, and f to the minus 1 of the reflection about the line, y is equal to x. This is worked example 1. Example 1 is on page 37. Okay. So here we are given the straight line y is equal to ax plus q. If f of x is equal to y is equal to 2x plus 2, find the inverse. Okay. So to just give you an idea, if I just draw this graph is going to look like this. Okay, so that's your y, your x there. We know for x-intercept that y equal to 0. So if y is 0, we take 2x over the equal sign, becomes x is equal to negative 1. For y-intercept, if x is equal to 0, so 2 times 0 plus 2 is 2. So that is your function. Okay, this is your f. We must take the inverse function. So what do I do for the inverse function? As what? X and y. So this is minus 1 and 0 becomes 0 and minus 1. Can you see that? If this is 2 and 0, it becomes 0. 0 and 2 becomes 2 and 0. Can you see that? If I take that into account, there is that graph. This is the inverse function. You see that, people? I must extend this here. This will come through like it. And then it will be reflected in the line. What line is this? Y is equal to x line. You see that, people? If I must go in and determine the equation of this graph, I know the gradient is changing y with change in x. So change in y is going to be 1 over 2. Or if you didn't know that, it's going to be 2 minus, sorry, change in y. So 0 minus 1 over 2 minus 0, which is half. Okay? So the equation of this line is y is going to be a half x plus c, which in this case is going to be negative 1. You guys understand? But now, for every time that asks us to work out the inverse function, we are going to draw the graph and determine the equation again, like as I did there. Okay, so there must be an easier way. So what we're going to do is we're going to follow the method given to us. Okay. So what was the first thing? What do we do? We replace f of x with a y. So in other words, your function should read y is equal to 2x plus 2. Okay. So what do we now say? For the inverse function, what do we do for the inverse function? We swap x and y around. So what will this now read? X is equal to 2y plus 2. What's the next step? Solve for y in terms of x. So make the y the subject of the formula. So how do I do that? Take the 2 over the equal sign. So 2y is equal to x minus 2. How do I get y in its own? Divide by 2 throughout. So y is equal to of x minus 1. And this is the inverse function of. That's the inverse function. You guys understand? Is the inverse a function? Yes. So I must say f to the minus 1 of x. If it was not a function, it was a relation, then I would have just written y is equal to half x minus 1. Okay? Yes. If you're going to write it, I'm going to penalize you. Anybody else write it now? You must penalize yourself, man. Otherwise you're going to get full marks. Huh? Alright? Will you guys understand? And if this one, Boitemelo makes that, then I will have to penalize. So from the second topic of the year, she's asked, okay, inverse functions. Inverse functions. So whole year she was practicing inverse functions. Okay. People, you guys understand? Any issues here? Carry on with the line. Example 2. In example 2, we're looking at the parabola, or the quadratic function. Example 2 is on page 38. If f of x equal to 2x squared, find the inverse. Okay, so what I did in the previous sum was I drew the graph to show you what's happening. I'm going to do the same here. Okay, so what we do is to draw this graph, I draw a table. Okay, why? Because a table reminds us of food. Huh? Right, let's go. The values we choose is negative 1, 0 and 1. We know it's going to be a parabola. Not so. So it's a quadratic function. So I put negative 1 in, I get 2. I put 0 in, I get 0. I put 1 in, I get 2. So if I must draw this graph, this is what the graph is going to look like. It's an x and a y. We've got minus 1, 1, 2, okay. So if x is negative 1, y is 2. If x is 0, y is 0. Origin, if x is 1, y is 2. Always see me writing at least 1 point on the graph. Okay. Either write that one or that, doesn't matter. So if I must take the inverse function, what do? Interchange x and y, not so. Remember that is f. So if I swap x and y, what does it become? Negative 1 and 2 becomes 2 and negative 1. And 0 and 0 remains 0 and 0. And 1 and 2 becomes 2 and 1. So there is that graph. Is this a function? No. Why? Does not pass the vertical line test. Can you see that, people? And this line going through here is what? Y is equal to? Okay. The reflected graph there. So what you see is this part of the graph here. See this part of the graph here? They're reflected in this line. Reflected in this line, y is equal to x, will fall exactly onto that part of the graph. Can you see that? And then of course the other part here, which is this graph here, will fall exactly onto it. Okay? But that wasn't the question. The question was, find the inverse function. Find the inverse. So how do I do that? How do we work out the inverse function, people? We firstly replace f of x with a 1. So in other words, y is equal to 2x squared. So what do I do? For the inverse function, inverse, what do I do? Swap x and y. So it's going to be x is equal to 2y squared. What's the next step? Solve for y in terms of x. So to get y squared on its own, I divide by 2 both sides. So y squared is equal to a half x. Now what? So you did use the square root, but must not forget. Plus and minus. Which means to say y is equal to plus minus the square root of half x. Okay? Is there any confusion there? No. Okay. Key concepts. For f to the minus 1 of x to be a function, f of x has to be a one-to-one function. The vertical line test shows whether or not the graph is a function. The horizontal line test on a function shows whether it is not an inverse. Not the inverse is a function. Remember, if f of x equal to 2x squared, then x has to be greater than or equal to 0. Alright, so basically what they are indicating there, where they are showing us, or they are reminding us, that these are not functions. The graph in red is not a function. Why is it not a function, people? Does not pass the vertical line test. There is no line. If you look here, it's not a function. Does not pass the vertical line test. So normally the question associated with this graph is, how do we restrict the question? You can write it down. How do you restrict the function so that the inverse will be a function? Okay, that's normally the question. How do you restrict the function or f of x so that the inverse can be a function? As we said, is this inverse a function? No. So if we only take this part of the graph, if we only take that and I reflect it, then it's going to be this part of the graph. Okay, so it's going to look something like this. If I only take this part of the graph, then that would be its inverse. So is the inverse, is this part of the graph a function? Yes. Why? It passes the vertical line test. Can you see there? Passes the vertical line test. So in other words, x must be in this direction. This is the function, don't forget. X has to be less than or equal to 0. You guys see that? Or do I take this part of the graph, that part? Okay? That is your function. And I reflected it in the line y is equal to x. It's going to be that graph. Okay, so it's the y is equal to x graph coming through here. So is the inverse a function? Yes, it passes the vertical line test. So, in other words, this is where x is more than or equal to 0. Okay, so again, how would you restrict the function so that the inverse will be a function? We'll restrict it by saying x is less than or equal to 0, or x is more than or equal to 0. I know in the previous in exercise 1's homework, they asked you how you're going to restrict the range. In an exam, they never ask you about the range. They ask you about the domain of the function. Do you guys understand? Is there any confusion there? No. So with that, for homework, I would like you guys to do exercise 2. In exercise 2, you don't do the whole exercise. They go further than what was required, okay? So in exercise 2, you're going to do number 1.1 to 1.4. Even 1.4 is further than what you are required to do. But I'll answer it for you anyway. Then you do me question 2. Question 3. Question 4. Question 5. Did I leave anything out? No. No. Okay, so I left the last 2 out here. Even this year, they never ask you this question. Okay, but I'll show you how to play around with that as well. Okay. And is here 6? Okay, then leave 6. Okay, let me just see what 6 is about. Yeah, I'll do 6.1 and 6.2. But I left the rest of it. Okay. So that's your homework for tomorrow. Again, we're going to record the exercise. Alright. The full lesson can be found in the description box below.